Good morning, my dear students. Today I am going to give the demo on QuickSort. Today I am going to give the demo on QuickSort. So then last class selection sort, last classes bubble sort, insertion sort, selection sort completed. Today we are going to discuss QuickSort. Simply, what is sorting? Sorting is a technique. Am I right or not? So it is used to sort n elements in an array using any one of the sorting techniques. Clear? Any one of the sorting techniques. So in an array, is either ascending or descending order. So arrange the elements in a particular order. That is called sorted order. Either ascending or descending order. Clear? That is called sorting. We know already we learned three sorting techniques. The first one is bubble sort technique. Second one is insertion sort technique. And the third one is selection sort technique or selection sort algorithm. So these are all the techniques. These are all used to arrange the elements in ascending order or descending order. Clear? So then the next sorting technique is quicksort algorithm. Quicksort algorithm. So quicksort algorithm, here quicksort is also a technique. Quicksort is also a technique. It is used to arrange the elements either ascending or descending order. So quicksort is a fast sorting algorithm used to sort a list of elements. Quicksort is a fast sorting algorithm used to sort a list of elements. Clear? Quicksort algorithm is invented by C.A.R. Hoare. C.A.R. Hoare. The quicksort algorithm attempts to separate the list of elements into two parts and then sort each part recursively. So remember, all of you, this is the most important point. The quicksort algorithm attempts to separate the list of elements into two parts. The quicksort algorithm attempts to separate the list of elements into two parts. Our given array divided into two parts. And then sort each part recursively. So the first part sorting and the second part sorting using recursive method. Clear? Then that means it uses divide and conquer strategy. In quicksort, the partition of the list is performed based on the elements called pivot. So then there is a new word is used in recursive quicksort algorithm, that is called pivot. That is, the partition of the list is performed based on the elements called pivot. Clear? So here using divide and conquer method. So to simply the array is divided into two parts using divide and conquer method. Here pivot element is one of the element in the list. Pivot element is one of the elements in the list. The list is divided into two partitions such that all elements to the left of the pivot are smaller than the pivot, and all elements to the right of pivot are greater than or equal to the pivot. So don't forget this rule. Two partitions such that all elements to the left of pivot are smaller than the pivot, and all elements to the right of pivot are greater than or equal to the pivot. Clear? All elements to the left of pivot are smaller than the pivot, and all elements of the right of pivot are greater than or equal to the pivot. Yes or no? Yes. So then your ascending order. So left side all are smaller than middle, then the right side all are greater than the middle. Yes, here pivot greater than and less than elements. Left side elements are less than, and right side elements are greater than elements of the pivot. In quicksort algorithm, partitioning of the list is performed using following steps. Consider the first element of the list as pivot, that is element at first position in the list. Define two variables I and j, set I and j to first and last elements of the list respectively. Increment I until list of I greater than pivot, then stop. Decrement j until list of j less than pivot, then stop. If I less than j, then exchange list of I and list of j. Repeat step 3, 4 and 5 until I greater than j. Exchange the pivot elements with list of j elements. Clear? So then these 7 steps available in the step-by-step process of the quicksort algorithm. For example, consider the following unsorted list of elements. Consider the following unsorted list of elements. Clear? Here 5, 3, 8, 1, 4, 6, 2, 7. These are all the array of elements or list of elements. Array of elements are list of elements. Define pivot left and right. Set pivot equal to 0, left equal to 1, and right equal to 7. How many elements are there? 0, 1, 2, 3, 4, 5, 6, 7. Total elements 7, 8 elements are there. Here simply the left equal to 1, right equal to 7, pivot equal to 0. That is 0 location value, first value pivot. Consider the first value is pivot. So some other examples, the last value is pivot. Some other examples, some other instructors will take the last element is the pivot. Okay. First, in this example, we take the first element as pivot. Left equal to first element, I mean second element. Right equal to last element. Clear? Last element. So define pivot left and right. Set pivot equal to 0, pivot equal to initial value 0, left equal to 1 and right equal to 7. Here 7 indicates size minus 1. Yes or no? Total size equal to 8, 8 minus 1 equal to 7. Because, so here lower bound value is 0, upper bound value equal to n minus 1, that is 7. Compare list left with list pivot. If compare list of left with list of pivot. Here compare list of left, which is the left value 3, and which is the list of pivot value 5. Compare. So here if list of left is greater than the list of pivot, then stop left, otherwise move left to the next. Clear? She is greater than the list of pivot, then stop. Otherwise, compare list of right with the list of pivot. If list of right is smaller than list of pivot, then stop right, otherwise move right to the previous. Repeat the same until left greater than or equal to right. Left is greater than or equal to right. If both left and right are stopped, but left less than right, then swap left of list of left with the list of right and continue the process. If left is greater than or equal to right, then swap list of pivot with the list of right. Clear? So then here compare in the first step. So here 5, 3, 8, 1, 4, 6, 2, 7. Clear? So this is right, this is left. The first one is 0 element is pivot. Compare. 3 is greater than 5. Yes or no? Yes? All of you? So compare list left, list of left less than list of pivot. So list of left less than list of pivot. Yes or no? Yes, it is true. Increment left by 1 and repeat the same. Left will stop at 8. Left will stop at 8. Then increment the left value, that is 8. So all of you. Then compare list of right greater than list of pivot. What is the list of right? 7, 2 is greater than pivot? If it is true, decrement right by 1 and repeat the same step, right equal to 3. Yes, like that. So right will stop at 2. Clear all of you. Right will stop at 2. So in this example, right will stop at 2. Next here, left and right both are stopped and left is not greater than right. So left is not greater than right. Yes or no? Left equal to 2, then right equal to 7. Clear? We need to swap list of left and list of right. Clear? List of left equal to list of right. So then, so here simply 5, 3, 2, 1, 4, 6, 8, 7. Here simply left and right elements are swapped. Here compare list of left less than list of 5 word. As it is true, increment left by the 1 and repeat the same. Left will stop at 6. So compare list of right greater than list of 5 word. List of right greater than list of 5 word. No, if it is true, decrement right by 1 and repeat the same. So right will stop at 4. Right will stop at 4. Clear? Then the next one. Here left and right both are stopped and left is greater than right. So we need to swap list of pivot and list of right. List of right equal to 4, then pivot. We need to swap it. Clear? After swapping, here 4, 3, 2, 1, 5, 6, 8, 7. After swapping, we will get the in array or list elements 4, 3, 2, 1, 5, 6, 8, 7. Clear? So next one. So here we can observe that all the numbers to the left side of 5 are smaller, yes or no? And right side are arranged in greater elements. That means 5 is placed in its correct position. So 5 is placed in the correct position. Clear? Repeat the same process on the left sublist and right sublist to the number 5. So this is left sublist, then this is right sublist. Clear all of you? In the first at the beginning at the introduction itself. So the list of elements can be divided into two parts. So using pivot, yes or no? So these elements are less than of pivot. Then the second array elements are right side array elements are greater than of pivot. Clear? In the left sublist, as there are no smaller number than pivot, so left will keep on moving to the next and stops at last number. Simply arrange the elements in a order. Clear? Here 1, 3, 2, 4. 1, 3, 2, 4. Here 1 and 4 interchanged. Clear? Left. Then the next one is 1, 3, 2, 4, 5, 6, 8, 7. Clear? Next one is 1, 2, 3, 4, 5, 6, 8, 6, 7, 8. So finally, so we will get the sorted order elements. Clear all of you? So then here simply arrange the elements. So first of all, initial value, pivot value is 0. That is starting value. So left value equal to 1 value. That is second position in the list. So right value equal to n minus 1 value. So in the n minus 1 list of n minus 1 value, initial values. Then compare. Then the next one, no. So first of all, we want to divide the list in two parts. Okay, like this here. So in the first left part must be less than elements of the pivot, and the right part must be greater than elements of the pivot. Yes. Then similarly, here left array arranged in a sorted order, and right array is also arranged in a sorted order. Finally, we will get like this. We will get like this. So we will get a sorted array. Finally, we will get sorted array 1, 2, 3, 4, 5, 6, 7, 8. Here quicksort algorithm. This is the very fastest algorithm. Clear? Is the fastest algorithm. Quicksort algorithm is the fast algorithm. Clear? So these are the time complexities of quicksort algorithm. Time complexities of quicksort algorithm. To sort an unsorted list with n number of elements, we need to make So n minus 1 plus n minus 2 plus n minus 3 plus so on plus 1 equal to n into n minus 1 by 2. Number of comparisons in the worst case, if the list is already sorted, then it requires n number of comparisons. In the worst case, order of n square. Here, best case, order of n log n. Average case, order of n log n. Clear? Worst case, order of n square. Best case, order of n log n. Average case, order of n log n. Best case and average case are same. Worst case is order of n square. Simply. So, what is the time complexity of quicksort algorithm? Order of n log n. Okay. So then merge sort algorithm, before going to discuss merge sort algorithm, I will show the animation. So I will show the animation, all of you. Quicksort animation, I will show the quicksort animation. Quicksort. Recursively perform 3 steps. Bring the pivot to its appropriate position such that left of the pivot is smaller and right is greater. Already discussed. So partitions, counter variables, index of smaller element, loop variables. We start the loop in pass 1. So in this example, the last value is pivot. So in the PPT slide, first value is pivot I took. So in this animation, the last value is pivot. 30 is like greater than 70. True, then L plus plus. L value equal to 1, J value equal to swap 30 and 80. Next pass 4, loop 4. 90 is greater than less than 70. No. In pass 5. Pass means loop. 40 is less than 70. Yes. L plus plus L value 2. Left 2. Then swap it. Next one. J is equal to 5. 50 is less than 70. Yes. Then L value equal to 3. Third value. Yes. Swap it. Before pass 7, J becomes 6. Then 70 and 80. Finally, 70 is brought its appropriate position by the partition function. Then this is first partition, then that is the next partition. Yes. So here 50 is the pivot. So pivot less than, pivot left side elements are less than and greater than elements are. So right side elements are greater than. Here 70, clear? Array is now sorted. All of you, I repeat the same. See all of you. This sorting algorithm uses the idea of divide and conquer. Yes, divide and conquer. Divide and conquer means the given array is divided into 2 parts and sort them. That is called divide and conquer. It finds the elements called pivot, which divides the array into 2 parts, in such a way that elements in the left half are smaller than pivot and elements in the right are greater than pivot. Already discussed. Yes. So some first in our PPT, in our presentation, I take left element is the pivot, starting element is the pivot. So in this example, the last element is the pivot. Yes. So which element you want to take, that one? Okay, no problem. Okay. Then the next one, in the quick sort. We recursively perform 3 steps. Bring the pivot to its appropriate position such that left of the pivot is smaller and right is greater. You quicksort the left part, quicksort the right part. Clear? Quicksort the right part. Note, in this video, pivot is selected as the last element. Here partitions. So here, this is a list of elements. This is a list. So many elements 1, 2, 3, 4, 5, 6, 7. Total 7 elements are there. The lower bound value, starting value 0, ending value n minus 1, 7 minus 1, 6. Clear? So in this animation, in this example, the last value is the pivot. Clear? The last value is the pivot. Counter variables, index of smaller element, loop variables. Okay. I is index of smaller element. J is loop variable. Clear? Next one, test condition, array of j less than pivot. So array of j less than pivot, then actions, value of variables. What are, if the condition is true, what are the actions are there, then value of variables are there, I and j values, L and j values, or I and j values. Here we start the loop with initial values. We start the loop with initial values where I equal to -1, j is equal to 0. Clear? Where I equal to -1, j is equal to 0, initial values. Start with the loop with initial values where I equal to -1 and j is equal to 0. Clear? Next. Array of j. What is the j value? 0 is less than or equal to pivot. So 10 is less than or equal to pivot. If it is yes, true, then I plus I value equal to 0. Swap array of I comma array of j. I value 0, j value 0. Then no change. Clear? Next one. In past 2. So j value equal to 1. What is the value? 1 value 80. 80 is less than pivot value? No. Yes or no? So no actions. Increment the j value 2 value. Now j value is 2. In pass 3, in loop 3, I plus I value equal to 1. Then compare. So here compare. 30 is less than 70, pivot. J value is 30. 30 is less than 70. Then I plus. So then swap it. 30 and 80. Clear? Next one. So if the condition is true, then increment the I value and swap the I value and j value. Clear? 30, 80 and swapped. Next one, j value equal to 3. 90 is less than 70, false. No change, no actions. J plus j value equal to 4. So then fourth value, 40 is less than 70. Yes. I plus I value is 2. Swap 40 and 80. Then j value equal to 5. 50 less than 70. If it is yes, increment the I value is 3. Then j value equal to 5. Swap both elements. Next one is before j value equal to 6. Okay, we know swap area of L plus 1. Then here simply, so here these two elements are swapped. Then all of you. This is the pivot element. So what are the elements of the left array of the pivot? 10, 30, 40, 50. These are all the left side elements. These are all less than 70. 90, 80. These are all right side elements. These are all greater than pivot. Yes or no? Now that 70 is brought its appropriate position by the partition function, we can begin quicksort the left part. Quicksort the left part. Then arrange the elements 10, 30, 40, 50. No change. already arranged in, okay, the recursive function arranged in the sorted order. Then take right. 5 smaller 30 and 10 also become pivot and left array over. Then quick sort, right array. So 90 and 80, swap it. Yes, array is now sorted. All of you, array is now sorted. So 10, 30, 40, 50, 70, 80, 90. This is the sorted array using quicksort algorithm. Clear? Sorted array using quicksort algorithm. All of you. Next one, same thing, same one I repeating. I repeat the same. Watch all of you. So this is the quicksort algorithm. Okay. Then tomorrow we will discuss merge sort algorithm. Tomorrow we will discuss merge sort algorithm. Okay, all of you. Today, sorry, today session is closed ended. Thank you. Bye.